Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of Pythagorean theorem on a coordinate plane. This is standard 8.7D in the great state of Texas, and we are using item number 36 off the 2021 released STAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have just a line here, line segment XY, and we need to find its length, closest length, and it's going to be a decimal here. And so how do we find the distance between here? Well, what we need to do is we need to envision this as part of a right triangle. So I'm going to draw a third dot down here. And you see it's right below my x and right to the right of my y. And if I can do that, then I can form a right angle. If I can form a right angle, now I've got a right triangle. And I know what to do with right triangles. So these two sides that form the right angle are called legs. And this side that we're looking for is the hypotenuse. It's always across from our right angle. And there is the Pythagorean theorem that we can use. A squared plus b squared equals c squared. So what that means is your two legs, they're labeled A and B, doesn't matter which one is which. If you pretend that those two are the side lengths of a square, so that's going to go off our chart a little bit. So let's say that this is b squared, because b times b is the area there. Same with my A. You make that a side length of a square, so a squared. If you take those two areas, a squared plus b squared, you will always get, no matter what, and that goes off the screen here, this hypotenuse squared, that c squared. Those two areas always equal the hypotenuse squared. So how does that help us? Well, when we're looking for missing side lengths, we can actually use this equation. So this a here goes from a y of 0 to a y of 6. So we're going to say a equals 6. And then we've got this b goes from negative 5 over to 5. So that's b equals 10. All right. So let's just plug it in. Let's say a squared plus b squared equals c squared. So I'm going to replace my a with my 6. I'm going to replace my b with my 10. All right, so 6 times 6, that's not 6 times 2, that's 6 squared, or 6 times itself. It's 36. This is not 10 times 2, it's 10 times 10, because it's 10 times itself 2 times. That's 100. All right, so we are going to get 136 equals c squared. Now, we're not done yet. We have not completely isolated the variable because we have that exponent. But the inverse operation of an exponent is going to be a root. So since it is a c squared, I'm going to take the square root of 136. And so that square root and that square, that actually cancels itself out. So we're just going to get c equals the square root of 136. Now we can't plug this into a calculator, but let's do this the old-fashioned way. So let's take our 136. Let's see what is below it, what is above it. All right, so if I were to do a 11 times 11, I will get 121. And if I were to do a 12 times 12, I get a 144. So you have to find the perfect square that's above it and below it. So that's what we're going to get. And you notice that we are 15 away from the 121, and we are 8 away from the 144. So we're actually a little bit closer to that 12. It's going to be 11 point something, but I'm going to say maybe 11.7, because that is going to be, that 8 is almost half of that 15. So it's 11 point something, and you notice we only have one 11 point something, and we actually did estimate that correct, 11.7. So our answer here is J.